Linux keyloggers and some quick overview about how to write some keyloggers in Linux kernels, and I did some other things. I'm Brandon from TSC, and actually the presentation will talk about three parts. The first part, I will have an introduction about basic how to roll some kind of kernel by keyloggers and how the keyboard drivers in Linux kernel work, and I discuss about some methods to help you to write some kind of kernel by keyloggers, and I also talk about some other tools which already and so you can write. The second part, I will talk about advantages in keyloggers approach which I will use in Keyloggers 2.1. And the third part, I will present the detail of Keyloggers 2.1, its overview, its features, use, and a short demonstration how to use it. The audience for this speech is supposed to know some techniques in Linux kernel local modules, so maybe just something like this. Yesterday talked about hacking with Linux kernel modules, or maybe some document like complete Linux kernel module from DSC website, so you can read about it. Actually, keyloggers is not new. It's been used widely in some hacking systems and in honeypots and even in some production environments. And the purpose of using keylogger is based on the user point of view. For security researchers, for administrators, it is usually used for monitoring, detection, documentation, the use of command system. In honeypots, it's used for capturing the activity of intruders without his knowing about the monitoring system. Black hat drives are usually used for collecting, stealing values, information, sensitive data, confident data from the system, from the users as much as possible, just like the email, password, your selective classified subscriber. And nowadays, encrypted channels such as SSL, secure cell are using widely, so you can no longer capture data of the wire by sniffing the connection. So that's why keylogger is an attempt to circumvent the encrypted system without packet. So here is a list of some current Linux keyloggers. You can see some user space keylogger like IOP, IT source, LKL, unit keylogger, and some other tools like keys. Which are by using some kind of dynamic preload libraries, and maybe another technique like LKL they use to read directly from the keyboard port to get some key scan codes whenever user type the key. But the main problem of user space-based keyloggers is very easy to detect. So that's why we have other time like kernel-based keyloggers. So there is some kernel-based Linux keyloggers like Linux 5 keyloggers and also keyloggers like today. Linux must be the first kernel-based Linux keyloggers we published in Frag magazine. I don't remember, like 50 by half-life. And a keylogger is also usually features and integrated some part of rootkit because it's the main purpose of rootkit, like have some background and getting some more information system. And also the CPAC, the hostband 24 monitoring is designed for capture data and capture the activity of attacker in the honeypot without it knowing about the monitoring tools. Then after that, it sends the capture data to some centralized login server. Here is quick pictures showing how creatures are processed in the Linux kernel. And you can see that when you press the key on the keyboard, and the keyboard will send corresponding scan code to the kernel drivers, and the handle scan code function in kernel drivers will process this, convert it to key code, and convert it to characters, just like key symbol by looking at some keyboard map. So after handling the character will be put into the TTI driver field, the put field functions, and after that the TTI line disciplines will radically call the receiver function to get the data from the buffers and put it into the TTI device buffers. So whenever a user process wants to get the input from user, it will call system code, and the system code will be called TTI res and get the data from the buffer. So actually, following the diagram, you can see that you can have some way to write a keylogger in the kernel base. One way you can set up your own interrupt handles, so your function will be called whenever you press the key. But actually, this one you cannot capture the remote session. And another one, you just hijack function. We show here, just like you can hijack the handle scan code function, push wheel, receiver, TTI, and secret system code. And here is some example code. That's how you can write some, just like interrupt handles. In this code, you can see that you can register your own interrupt handle, and in your interrupt handle, you just log the scan code when user press the key, and the keyboard will generate the series of scan code. For normal alphabet character, it will generate only one scan code, but for some key combinations, it will then upload like 6 sequence scan code, and you actually have to process them at once, just similar to the handle scan code function does. So here is an example how you can hijack the handle scan code to capture the key code in the kernel. Actually, handle scan code is not an exported function. So normally, if you write LK module, you cannot access to handle scan code function. But you can still hijack this function by using some technique called kernel function hijacking, published by serials, and I will give you the link at the end of the slide. In this example, you can see that you can find the address of handles scan code, and after that you can override some assembly instruction with you to your own handle scan code to lock the keyboard, the key event, the kernel functions. This way you can see on serial papers. And also you can see my article in the 59 issues, article 14 for more detail how to hijack handle scan code, receiver, and also secret system code. And actually there is many ways to do keyloggers in kernel. The most common method for writing a kernel-based keyloggers is hijacking read or write system code to log data passed into them. Actually, you can see that Linux by or keylogger we have shown before. They also see what they all use the way to hijack read system code to log data. By hijacking read system code, you can have the ability to log data of all user sessions, and you can log not only keystroke but also all data passing to the user session. We mainly focus on captures and keystrokes. Unfortunately, this way it actually slowing down the whole system because you have to intercept every read task with read system code. So that's why it will make your system it will slow down your system, especially always on just like heavy load box. And hijacking the system code is very easy to detect, and actually you can disable it completely. So I will show you how a common method to lock the keyword in the kernel. This is the diagram how CWAC kernel module capture the keystroke from the intruder in the honeypot machine. So you can see that they just redirect the read system code to their own read code and lock data and call the original read. Very simple, and it is also very simple to detect and disable. And this one is a tool which was published in the Frankfurt 62 by some guy in EMS. And this one is very simple, just find the syscall table and point the read system code to the original system code. So this will disable the keylog module completely, so the CWAC cannot log the intruder's keystroke anymore. So you can go to the link to read more about the Frankfurt article about local honeypot identification. So now I will introduce some new advanced methods to be used in VLogger 2.1 to acquire more ability and harder to detect also. We combine some modules hiding or loading with the K-man device is nearly impossible to detect. So, and so because we can lock the key job in the kernel by hijacking key processing functions in the kernel, and this way I chose to hijack the receiver function. Receiver function is called by low-level TTI driver to send character to the line systems for processing, and you can take a look at the kernel source of TTI drivers, and you can see this one like CP forwarded to the buffer input characters received by the device, which means the handle and scan code will put on the key sync to its buffer, and FP is the pointer to a set of flag about parity and around count is number of characters in the buffer. Usually the count is 1, but when you put some combination, just like combinations of key in the keyboard is with more than 1 character in the buffer. And this one is structure of TTI structure and TTI line systems. You can see the receiver function. So to capture screenshot, we can set the receiver of the corresponding TTI driver to our own receiver function. This is an example of how you can lock screenshot from the TTI host device, and this code run in kernel side. You just open the device and get the TTI structures and set the old receiver and assign the receiver of TTI driver to our old receiver. Then we load the data code to our receiver function. However, at the examples, you can see that actually the TTI structs and field are dynamically allocated. So that's why when user open a new session or close the session, you can no longer capture the keystroke of the new session. That's why we need somehow to dynamically hook the receiver function of TTI or PTI when it's the import. That means we have somehow to dynamically hook the receiver of every new session. So there is some solution for this problem. In my first video class, I showed the way to intercept 6 open system call. So our own 6 open will be called whenever the user opens something. And if we check it in the TTI device, and we just point the receiver of that TTI device to our own receiver. But this one is also easy to detect and also can be disabled completely. So in the new VLOOKUP 3.1, I choose another way to do this by intersecting the open interface between low levels TTI drivers and TTI routines of TTI drivers. This is why it's quite complex, but you can see how we can do this. This one is TTI driver open interface first. Further, you need to somehow find a head pointer of linked list in registers TTI drivers. Actually, you can use some trick in the kernel to get the encoder is one, and the detail you can see on the code which you can download from our website or contract website. First, we replace the open interface between the low-level driver and design routine or design drivers which we want to hook. There's actually a lot of different kind of design drivers. Driver for virtual console, for stereo console, for remote session, PTI, maybe some interest for or whatever you want to lock, you can hook the function of open function of the driver. In this case, you can see some code which replace the open interface of PTI drivers. And after we hijack the open functions of low-level PTI driver, you can dynamically hook the receiver function of every PTI or PTI when it is involved. So here is some example code how to use this way to lock the features. And actually you can set the new driver open just like virtual console, serial console, PCI, and whatever you want. After that, whenever the new drivers open call, you can set the receiver of corresponding PTI driver to our new receiver function, and in the receiver function we can lock the data and call the own receiver. Okay, so now I will present the developer 2.1 and talk about its features, how to do it, and some capability of locking features and some more, and some more of the tool. Actually, the main feature of developers is lock features of all user session. That means the session with console, serial console, remote session like LNS, SSL, or whatever with involve the PTI. And it supports multiple lock modes and multiple lock methods. And it's don't use the way to do not modify any system code table, and actually it's very hard to detect. If you convince the developer with some module hidden or loaded with the payment device, so it actually is very hard to detect and mostly impossible to detect. And the new feature of developer is remote locking. That means it can send the feature to the centralized developer servers, and actually with developer network code, the network packet of the data cannot be seen from the box. That means the firewalls, packet filter or snip, it means so just like distributor cannot see the packet. Developer support 3 lock modes. There's smart and normal small. In the also just symbol of all spiritual of all session. In smart mode, it can automatically detect the password form and to lock only sensitive data, just like username, passwords, secret cell, telnet to zero activity session, and just like your PCB directly passphrase or whatever. And how to detect the password from? If this one is quite trivial, just like you assume that for entering the password, the application just turn the input and going up. So this way, very simple, just similar to the previous present in passive analysis of saving cell traffic paper published by Solar Designer and the shop, and you can go through the link. Rest more about it. The symbol is like you log the command, and when turning on and off echo, and you start the data. And with VLOGger you can always switch between log modes by press some specific key sequence which you will set when you load the modules. And to switch mode, you just press the message backward and the toggle key, and we will switch the logger. VLOGger support through log methods. The normal way is to log the data to files stored in the system. The other way is remote logging. That means transmit the log data via the network to a specified VLOGger server. So I said before, the system admin cannot see or not see the VLOGger packet from other machines located in the network. By creating, routing, and sending the log packet to the destination directly with corresponding network device. So it can bypass the network filtering in the box, and if you set some fast IP address and fast port, and you can also bypass the firewall restriction on the network. VLOGgers also have the old buffer for every session, so that means you will be very easy to track the session and integrated some advanced processing features into the VLOGger. So actually you can more easy to track this session, and also you can add some more features. VLOGger also support timestamp logging, and we support just like can detect all special charts like row keys and 1 to 8 trails, key combinations, path inserts, whatever special charts. And because every session has their own log buffer, so that means VLOGger support line editing key, so you can have a very clean log data for easy to analyze the log. You will need to have a kernel source and kernel header to compile the VLOGger's models, and after that you can use the VLOG config tool you can edit the configuration script manually. So here is some option you can edit in the vlog controls. Just like log method, I mean, you choose way to store, switch off on the file, or send to remote network with the servers. Log data, when you choose to store on a local file, choose this to store the data, destination, every destination port, short, IP ports, and many other options. To run Vlogger, you just use Vlog controls to load and unlock module. But remember that when you configure the Vlogger modules, if you choose to hide the modules when you load it, you cannot unlock the module, or you cannot see the modules in the module list. And there is also a symbol with local server, so you can run it to capture the data sent from the local client. So here some output that you can see and have a figure how the vlogger works. This is in the box. You can see it's a session in different files, and you can have the time, OID, user IDs, the command, and the data. This one, the most. Is smart mode is just capture sensitive data, just like password or username, and you can see it will log the time, date and time, tt8 numbers, user ID, the command, then the parameter command, and the passwords. And this can work on most of tools with require you to enter the password, just like Excel, activity, and in the network, most you can just load the Vlogger modules on the client, and you run the Vlogger servers on your box. So it will listen on the UDP port and get all data sent from the client. So you can see like log from the IP, tt8 numbers, the date time, user ID, the command, and the data. So today I will do some brief demonstration after the talk. So actually you have to combine the tool first. Actually I combine it first. So after that, you have to configure some option by using the config tool. Actually, show the magic password for switching the lock mode. Just like you can set the time zone, you can choose the lock mode, and also the default lock mode. And this one will go lock mode when you lock the volume, but actually you still can switch the lock mode by press the sequence of magic password and the toggle key and the directory to start the data. And with this option, it will, if you answer yes here, and when you load the modules, it will automatically hide the VLOOKUP module, so you can no longer remove the VLOOKUP module, and you can no longer see the VLOOKUP module from the module list. So I have set down here. You can lock. Capture that look like S1, and now we have two systems. You can see that two separated log file, and you can see the desk time and UIDs, the command and the data time. And this one is the demo, and you can always switch the lock mode by pressing the magic password and the toggle chart. In any application, you can type in whatever application the magic password and press the toggle chart. It will automatically switch the locking mode. So this one is now the smart mode, which will lock only username and password and send the information, just like if I show you some other username. Only the username, password, and the command is parameter on scale. So actually, this one can lock most of applications will need you to enter the password. Most will no longer lock the data for temporary. Actually, you can always switch back to the normal. It's very easy. If you want to remove also you can set to choose the network protocol. And you can set the fake short IP address to send, and you can enter and it will automatically use the IP address of the output device. Short port you can set whatever, maybe you can set the short port to some DNS port so it can bypass some filter rules on the gateway. And you can set the IP address of the server, destination port, you can load into that. And now you can run the server to this thing on the same in local host, just like the IP address on the client, the tt8 device, that time, user ID, command, and the data. Don't choose the hiding features of developer, and whenever the administrator do some kind of list models, you can see the developer models on the top. So in case you want to hide the models on the list, you can set the developer config with you answer yes here. And unload the whole and load it again. And now you will not see the developer models on the models list. So actually if you choose this option, you can no longer remove the developer models, because actually the models information in the kernel can be changed and it remove the developer models from the list. So actually you cannot remove the developer models in the kernel anymore. So this will run stably. Actually the administrator of the workload will actually very hard to detect the developers running on its spot, because especially in the network mode, because it don't share any data on the box, and it actually don't create any connection to the developer server. It's just automatically generating the packet and sending directly to the network device. So actually it's very hard to detect. So this is at the end of my talk, and maybe if you have any questions, you can ask me and talk after either lobby or. So if you want to download the developer 2.1, you can visit our website www.tat.org, or you can download it from the conference website. And there's also a lot of tools and papers on our website, so maybe you can visit the site and take a look at it, because actually there's a lot of very useful tools and papers and many other things on our website. So it's just really try. Okay, thank you. Any questions? Yeah.
Hi, how do you handle like secure shell or S copies? If someone does a secure shell copy, does it log an entire file transfer into your log file?
And you mean the CPAC have a feature to capture the secure copy?
Like you're logging everything when someone does an S copy, you also yes, you have to log an entire.
Actually, it can be done, but we just like our tool, I mainly focus on capture the feature, so I skip a part. But actually, it's because if you hijack the REST system code and you can capture whatever data transfers to the REST system code. But actually, this one I just focus on the feature processing function, so that means it don't care about other part of the system code, because actually the system code is used for many things, just like reading the file and the network socket or whatever.
Seems like if you have network logging enabled, so you log into your VPC socket and somebody has copies like a 20 meg comparable of your server that you're logging on, all that data goes through the PTS, so you're not sending 20 megabytes of data through your VPC socket too. So do you have any plans to add a protocol detection into it so it can see that, hey, they ran scopy-t on the one side, see that they're doing a file transfer and avoid it, or stays off or something? What's crazy plans for implementing any like file or protocol detection stuff on the PTS side?
So you mean implement some kind of the secure copy files?
If you're doing
similar to CPAC?
Well, not like when you do an S copy, it actually just runs secure shell on both
Yeah,
sides. Yeah,
so actually you can do it with some kind of hijack the file operation structures, and you also don't need to intercept the REST system code. You just intercept the REST operations of the file, just like if you have the tt8 or 3 or maybe 3 service or what kind, is have its own internal structure for REST operation, so actually you can hijack that function, and actually it's very hard to detect because there's no way to detect it twice. So this will the same as the So any other questions?